Alkanes are the hydrocarbons, and the carbon atom has only sp3 hybridization. So that makes them have no pi bond. And so these are some examples of simple alkanes. Propane, three carbons, butane, 4, pentane, 5. Their name all end with ane. And the alkanes can be also have the ring structure. This is 3 carbon in a ring, and a cyclopropane. 4 carbon. This is also 4 carbon. So we still use the root name as a butane, but this have a ring, so the name we add a cycle in the front. All the rings have cycle in the front. And likewise, cyclopentane looks very nice, pentagon. Hexagon, that is a cyclohexane in organic chemistry. So this is the alkanes, very basic alkanes. You are supposed to memorize names. The most important alkanes to memorize names are the alkane with 1 to 10 carbon atoms. Remember these 10, because more than 10, the naming will follow the same pattern, and it's fairly easy. And so among the 10 carbons that you must memorize, the first 4 are kind of unique. The 1 carbon is methane, 2 carbons ethane. So they start with we call it parents. The end of the word, or we call it suffix, are all ane. The prefix are the we also call it parent. 1 carbon is methane, 2 is ethane, 3 is propane, 4 is butane. These 4 need to memorize, because for the others, they look familiar. Penta means 5, so 5 carbons pentane, 6 hexane, heptane for 7, 8, 9, 10. These prefixes we learn in the naming of the covalent compounds in the general chemistry, introchemistry. So these are the alkanes that we need to memorize. What if more than the 10 carbons? More than 10, we add this piece. For the deck means 10. The undercane is 11. This undercane actually come from Latin or come from Latin language. Uno means 1. So basically 1 plus 10 give me 11. Dos, so dodec means 12. Tres for 3, so that's the Spanish is basically the same thing. Tres plus 10, so 13. Tetra for 4, penta. So these actually, from this point, it becomes familiar again, essentially. Essentially, we have those. These, I don't ask you to memorize, and actually I don't. And so the basic naming of the alkanes. These are the parents. When you have a very complicated alkane, when you name the parent, the longest chain, you use those names at the very end. Alkane naming, we use only the IUPAC system, the International Union of Pure Applied Science Chemistry. This organization defined the system to name the alkanes. And so for this compound, we have we look for the longest chain. And once you decide which one's the longest chain, you give the branches, those branches, as a small number as possible. These we call them branches. These are the longest chain. We call it parent. So once you know this, you know the parent, that'll become the last part of the name. And then about those branches, so small pieces out of the main chain, we find the location for them. and use the location to tell people where are the those branches and how many of those branches. And you can see the position 2 and 3. Each one have a CH3. The CH3 we call the methyl group because they come from methane. And the position 4 has a 3-carbon side chain. The 3-carbon side chain is supposedly coming from the propane. And this is one of the propane based branches. We call them isopropane, isopropyl. So the location 4 we follow by the name of this group, this branch. So it's very straightforward system, but it takes some practice to get used to. And so first, what is parent chain? The parent chain will give us the last name of this compound, the last name of the compound. And it is supposed to be longest consecutive, there's no break. Longest, okay, the longest consecutive non-break chains. Substituent, inorganic chemistry, we basically call them the side chains. Side chains, the smaller pieces. So you can treat the parent chain as a stem of the tree, and the branches are the substituents. This will be the stem of the tree, and the other smaller pieces are the branches. And so those, this we call the ethyl because it comes from a 2-carbon alkane, which is ethane. This branch have 3 carbons. It comes from propane, and each one will have a specific name that is based on the alkanes. This is 1 carbon, so come from methane. The parent chain naming, this is we've seen it before, and this is basically a repeat of what we see the previous slide. And this is an example, shows you when you have a molecule have this kind of shape. What is the longest chain? This takes some practice. We need to find the longest chain in the structure. So for this molecule, you basically use a trial and error. If you're not familiar with this, use trial and error. Let's say I start from here, start from this number 1. I try to look for the chain that has the longest, the most atoms. If I start from here, then 1, 2, 3, 4, 5, 6, 7, 8. I have 8 atoms in the longest chain. If you start from here, okay, this is the 1. Start from the second option. The second option, this is number 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 atoms. This is better than my first choice. So this is definitely not the way to go. Let's keep trying. Let's keep trying. Let's start from here. Let's start from here and to here. You will find out also have 8 atoms. So this is not a good start either. Go this route will not give you the longest chain. Okay. So basically the key is to find out the longest chain. Take some practice. And we have the Canvas quiz for you to practice on. The naming of the substituents or the branches. The first one, when you have only 1 carbon, that's a methane because it comes from methyl, because it comes from methane, the alkane. The B, it has 2 carbons. It comes from ethane, so we call them ethyl. Basically, each case, we substitute ANE from the alkane, replaced by YL. L. That is the name of the substituent. The C has, this is basically the parent, okay, whatever parent is. This side chain have 3 carbons, so it's a propyl, okay, from propane. D is isopropyl. The difference between the C and D, the difference between C and D is for the same alkane, the propane, the propyl has end carbon, remove hydrogen and attach to the parent. Isopropyl, it is the middle carbon. The middle carbon take away hydrogen and attach to the parent. So the difference between these two, be very careful. This is a very commonly used substituent in organic chemistry naming. Okay, next we're gaining basically more and more carbons in the side chain, the substituent. This has 4 carbons, and the end of the butane attached to the parent. So this we call N-butyl. N, I believe, means normal. N means normal. Okay, this means N-butane. N-butyl, it comes from the butane. This side chain also have 4 carbons, but this is number 2 carbon form bond with the parent. So this we call sec-butyl. Sec-butyl. And then G, there are also 4 carbons, 1, 2, 3, and 4. But this side chain substituent, it starts from a alkane that is one of the isomers of butane. Come on here. The middle carbon will take away the hydrogen and attach to the parent. So this we have a special name, tert-butyl. Tert-butyl. And this is actually very popular in organic chemistry research because this group, it has so many hydrogens and they all close together. Is a very bulky, it looks like a tree, very, very prosperous tree. It has big, occupies big space. In organic chemistry, we oftentimes use that. So remember, this is the butyl. The other butyl, especially sec-butyl, I don't really use that much. We don't really use in the organic chemistry. If you memorize it, that'd be great. But tert-butyl and N-butyl are the most common in organic chemistry. Make sure you know that. The H is also have 4 carbons in the side chain. And this is also come from this 4 carbon alkane. But we use the one of the methyl group take away hydrogen and attach to the parent. This is isobutyl. Okay, isobutyl. And getting to this point, if I keep going, it's getting more confusing, especially the sec-butyl and the isobutyl. And these two, in organic chemistry discussion, we don't use that much. So don't worry too much about these two, because oftentimes I don't remember these two. Okay, so don't worry about these two. If the side chain start from a cycloalkane, a ring, one of the hydrogen on the ring being removed, and then that attached to the parent, you just simply replace the last 3 word ANE by the YL. You get the name of the group. So this have 3 carbons. We call it cyclopropyl because it comes from cyclopropane. If the substituents are the halogens, we just simply name them as they replace INE by 1 letter O. So fluorine becomes fluoro, chloro, bromo, iodo. These are the branches. We call them the end with O. It's very similar to the transition metal complex. When we name the ligands made of halogens, we used INE replaced by the O to name those substituents, the ligands in the transition metal complex. So these are there's some more details. We don't need to memorize those more advanced. I think for this slide, we do need to memorize the N-butyl or butyl, tert-butyl, these two. The others, Well, this one have 5 carbon. You either call it N-pentyl or pentyl. Both are fine. To make it simplified, we just name it as pentyl when you have a 5 carbon and no side change on the, no branches on this substituent. Naming those alkanes, the first step is to find out the longest carbon. And this takes some practice. And so whichever, when you count the number of carbons, whichever the way you count give you the most number of carbons, that will be the parent. Okay. So basically, this is about using try and error, especially when you are beginning. You don't know where to start. You just start, pick one atom. I will do the clockwise. Start from my 10 o'clock, and then one by one, start counting. Start counting which one gives me the longest number of, the most number of carbons. And so with this molecule, you just try, we can either start from here as my first attempt. And later I can start from here. Later you can even start from try here. And count toward the other one, find which one gives them the most number of carbons. I think most of you would agree this will be the end if you start counting from top. This will be the end because that'll give you the longest trip. Okay. You can start from here also. If you're trying, which one gives you the most? Not so much you. Remember, this is a visual. You don't just use some definition to find out the best way. Unless you're a computer scientist, you want to find a program to name the compound. That'd be great. That'll save a lot of trouble for organic students. If more than one possible parent chain, which means there are 2 ways, both give me equal number and the highest number of carbon atoms. Which one will be the best as a parent? The rule is whichever has the most branches, most substituents. So for this molecule, if I start from this end, 1, 2, 3, 4, 5, 6, 7 carbon. Okay, 7 carbons. The red will give me 7 carbon as a parent. For the same molecule, if I start from here, instead of going this way, I go left. That also give me 7 carbons. But the difference is the left hand, I have 3 branches. Those green box have 3 branches. And if you name the right hand, I have only 2 branches. This is the ethyl, this is isopropyl. This is not good because there are only 2 branches. This one's better, I have 3 branches. Okay, so with the most branches will be the correct way. So this is a little practice. Name the following compounds, and we just try and error. Start from this will be this one looks like give you the furthest away from the other end. This is a good starting point. If I start from here, 1, 2, 3, 4, 5, 6. Once getting here, it's like getting to a fork, getting to a crossroads. I need to decide where should I go. Okay. If you start from here, I can either go my 2 o'clock or go down to 6 o'clock. Okay, go down. Or go left, 7 o'clock. Okay, you can see go 7 o'clock is not the way to go because I'm too short. Between the 2 o'clock or 6 o'clock, no difference. So let's just go with this one. 1, 2, 3, 4, 5, 6, 7, 8. From here to here, give me 8. So start from here, give me 8. Label that. Let's try the other one. If you go this way, start this one. 1, 2, 3, 4, 5, 6, 7. That's going to give me 7. So this is not good. And So if there's no other options, if you pick this, it'll basically do the reverse. You don't need to do the same counting, do the opposite way. Just pick one way. Anyway, start from 8. There should be 8 carbons in the longest. So the parent name will be the 8 carbon. 8 is octane. So this first one's octane. For this, give me the parent name. This is a molecule with a ring. Okay, with a ring depends on how many carbons in the ring versus how many carbons in the out of the ring. In this case, the ring have 7 carbons, and the longest chain that is outside the ring have only 4. So in this case, we should pick the one that has more atoms, the ring, as parent. So this is more atoms. The parent will be the cyclohexane. Okay, cyclohexane. If there's rings, depends. And the next step, we identify the substituents, basically meaning you find out if they are methyl, ethyl, propyl, butyl, and so forth. And that those alkyl groups just need to memorize. And that should be the easy part. Take some practice. For me, it's easy, but for beginners, it takes practice, identify the substituents. And so this one have 2 carbons, that'll be the ethyl. This have 3 carbons, that'll be the propyl. And this is 1 carbon, the methyl group. So we have 3 different substituents. If this ring, like I said, if the ring exists in the structure, depends on either ring or the non-ring structure has more atoms. If the ring has more atoms, the ring will be the parent. But if the non-ring section are longer, more carbon atoms than the ring, then the longest non-ring structure will be the parent. So you can see here, this is the molecule. You have a hexagon, that is cyclohexane, and the non-ring have only 3 carbons. The non-ring have only 3 carbons. So between these two, the more 6 carbon in the ring, that'll be the parent. And outside the ring will be the branch substituent. 3 carbon outside the ring, so we call that a substituent as a propyl. And the parent, since it's 6 carbon, we call it cyclohexane. And if you look at the different structure, this molecule, the ring have 3 carbons, triangle. And the non-ring have 1, 2, 3, 4 carbons. So non-ring has more carbon than the ring. Then we name the non-ring as a parent, ring as substituent, or the side chains. So the name for this, this is parent, so the butane, and this substituent we call cyclopropyl. And then the next step we'll decide what number for those. That'll be the next step. The naming, it takes some practice, new rules. With Zeppelin, you have plenty of practice. And also we have online quiz, multiple choices, multiple chances. Keep practice on that. This is the same molecule from the last slide. This structure, we decided this will be the longest. Very important, keep that in mind. Then beyond the longest chain, these are the substituents or the side chains. So the side chains, this is 1 carbon, so the methyl. This is also carbon, also methyl. So methyl for both. And this side chain substituent have 2 carbons, so that's ethyl. That's 3 substituents we have. This is the same molecule we saw before. And we decided this would be the parent because it has 7 atoms. So this is the parent. Substituents are these 3 pieces. And this one have 4 carbon atoms. So this is butyl or N-butyl. Butyl. And both have 2 carbons, so that's ethyl. Both are ethyl group. Complex substituents. The complex substituents. This is the example shows when you have a side chain, it's very complicated, more than just methyl, ethyl, propyl, butyl, and there's some other related. More than those, then we give a name and numbering on the substituents. In the substituent, the carbon that is linking with the parent, we label that as number 1. Okay. The parent is number 1. The atom that links with parent is number 1 carbon. And then within this complex substituent, you still need to find the longest chain. It's almost like a parent among the substituents. We go this way, and we don't go this way. Because it goes this way, give me only 3 carbons as substituent. Go horizontal, will give you 4, the longer main chain. So once we decide to label the 1, 2, 3, 4, and then 1 through 4 is a parent. Number 2 has a one carbon as a side chain. This is methyl group. So we name the substituent as based on this number system. Number 2 has a methyl group, so it is we call 2-methyl. And the longest chain in this complex substituent, it is 4 atoms. So it is the last part name will go butyl, because that is longest in the substituent. Position 2 has a methyl, so 2-methyl. This will be a group, complex group. So in the actual naming, it is we put the name of a substituent, which is complex substituent, inside parentheses. And then finally decide which one in the ultimate parents, what location have the substituent. This component we have a name for this. Let me get to. This is the longest is a parent. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the parent name will be the alkane. It's 11 carbons. And position 6 has this complex substituent. So the name of this will be the 6 hyphen, and then add parentheses. Everything that we have here, we'll put inside parentheses. I'm making one word. So that's the ultimate naming for this complex alkane. And so far sounds like a complicated, but as you practice, it's a fairly easy rule to follow. And definitely give you a chance to practice on those. Naming the entire compound, now we put them together. We have the longest chain, and the second find out the most substituents, and then the recognized substituents, the side chains, and then we deal with complex substituents. Finally, we're ready. We find that we put a number on the parent. When you put a number on the parent, the end is number one carbon. Okay, this is number one carbon. With this molecule, the numbers on the parent, it is just like street number. When we locate the house, we need to offer the street number. We have a 100 main street. 100, it shows you what location on the main street has a house. The same with the organic chemistry. The numbers, it tells you what location on the main parent has the side chains, has the substituents. Those numbers, we call them locant. And so these two molecules, the longest chain, both have 5 carbons. That make them parent name end with a pentane, both end with a pentane. But the difference is with this molecule, position 2 has carbon, so 2-methyl pentane. And with this molecule, the middle carbon, number 3 carbon has a methyl. So that is the 3-methyl pentane. They are isomers, so they have the same parent name. Isomers basically have the same structures, if you don't quite remember that. Okay, sometimes there are more than one way. Oftentimes, there are more than one way to give you the longest chain. Actually, whenever you find out the longest chain, you realize you can either start from the very first atom or from the last atom to the counting. Either way give you the same number of carbons, and of course. But not both ways are correct when you name the compound. The rule is, if there are only one substituents, whichever the numbering that give you the lower number for that substituent, it is correct way. So for this molecule, I can either start from the left to right, do numbering, give numbers for the carbon, or come from right to left. Both give me 7 carbon, no problem, both seems right. But you should pick the way that give you the substituent have a lower number. From left to right, this is location 2, give you methyl group. If you number from right to left, position 6 have a methyl group. This is not good because it's 6 versus 2. Okay. If you have multiple substituents and both way, the rule is give the first substituent the lowest number will be better. So this molecule from left to right, the first substituent position 2. If you start from the other end, start numbering from right to left, the first time see the substituent is as on position 3. Because this gives you 2 have substituent, this one 3 have substituent, this is better. Okay, so the naming organic compound sounds like a lot of rules. Unfortunately, just need some practice. It's very quick, very easy to master. If there's a tie, okay, so all these are hierarchies. If there's a tie on the 2 directions, both directions, the first substituent start from the same number. If there's tie, then the second locant, the lowest, will be better. So for between these 2 molecules, the location for the substituents are 2, 3, and 6. For the right molecule, if you start from the opposite direction, start from the left hand as number 1, the location or the locant for substituents are 2, 5, and 6. Between these 2, 2, 3, 6 is better because the number 3 is smaller than 5. Okay, if there's no tiebreakers, there's no tiebreakers. This is a situation. You have a long alkane. Both end has each end has one halogen, and these two halogens are different. And so if you start from the this is the left-hand side molecule. Start from this carbon is number 1. 1, 2, 3, 4, 5. When you start from here, the I'm not sure you can see that. I cannot see them myself. The numbers I need to write. Okay. Can you see the PowerPoint still?
No,
Can you guys all
yes,
see?
Professor, yes.
Yes, PowerPoint. Yes, PowerPoint. Okay. So the this molecule, it position 1 give you bromo, position 5 give you chloral.
It's on
The other way.
yeah, it's on the delocalized versus localized PowerPoint.
What? Oh, never mind. Sorry. I need to share this one. Oh, okay. Yeah, I see. Yeah, once you get out of full screen, there's changes on the. Okay. Now it should be see the structure. This naming will be 1 bromo 5 chloral. Okay. And this naming will be 1 chloral 5 bromo. The bromo alphabetically is before the chloral, so give the low number for bromo is better. That's why this is better. Okay. That's if there's no tiebreakers. Okay, so there's a lot of rules in naming. It takes practice. And keep in mind, these are man-made rules. And the Alkane chapter quiz, we have a significant amount of weight coming from the naming alkanes. Take some practice. It's not that hard. And I don't give you extremely complicated molecule for you to practice. Know the basic rules. And so these are the more lower numbers, the preferred. This is the cyclohexane naming. You can go clockwise, start from the, remember we want to give the substituent low number. So the carbon has more substituents. Start that as number 1. Okay, so this will be number 1. And this will be 1, 2, 3. For the same molecule, if I start from here as number 1, the difference is the number of methyl groups will be different. Because if you start from here, number 1, clockwise, and the location for the methyl group will be 1, 1, 3, both on the position 1. So 1, 1, 3. If you start from this number 1, position 3 have 2 methyl group, so the it'll be 1, 3, 3. This is preferred. Okay, this is preferred. So basically, when you name organic compound, keep trying. You might come up with a first name, and you think you're pretty good. Even though you might describe all the substituent correctly at the location properly, but your name may not be the best. There's a lot of rules to follow. The alphabetic rule and the number rule, the low number the better. The number rule and the alphabetic rule are the 2 most important rules in the naming organic compound. And finally, just add together. Okay, finally, just add together. If there are more than one of the same kind of a substituent, let's say you have more than 1 methyl group, you just add the di-tri, those prefixes to describe. 3 methyl group in the structure, then that is a trimethyl, and so forth. The iso, when you have a propyl group or methyl-butyl group starts with iso, the iso counts as part of the name, part of the whole substituent name. That's the rule we have. We'll see some examples later. Okay, so for this compound, position 1 have 2-methyl, so this compound naming will be 1, 3.
Professor, I'm still a little confused. Why is it 1, 1 and then 3?
That's the way we name compound. These 1, 1 for location.
Okay.
There's a lot to go over, but let's do some real naming, and we're kind of out of time. Name this compound, we need to find the longest. And then normally I will start from the up left corner, start from 10 o'clock, and end with 6 o'clock or 2 o'clock from left to right. You can have your way, you can have your whatever way you like. There's no fixed ways. So if I start from here, this is number 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is one way. If you start from here, the first one, that should be the same as my first, no difference. So this is not really different way. No, it's symmetrical as the first one. If you try to start from here, you can see that this is very obvious to give you shorter main chain. You don't start from this one. This is fairly direct. You can just counting or by visual. So basically, this will be the main chain. If I decide to go down, okay, let's say, let's say, oops, my color didn't change. I want to change to different colors. What? Oh, there we go. Well, you find out that there's less carbon. You don't want the green route. So the longest, you go this way, and then we find the substituent. This is one substituent. This is another one substituent. Since we go the red route, this is substituent. And here, if you go up the red route, then this is substituent. So those are substituent we decided. And then the next step, we need to decide how should I put number? Should I go from here or go from here? Give number. Okay, remember when you find out the longest parent, there are 2 directions you can give numbers. Pick the one that follow rules. Okay, there's rules for that. If I go from left to right, position 2, position 3 on this carbon, I have an ethyl group. Okay. If I decide from here, from here, go down, position 2 has a methyl group. This way is better. Okay, because this way give you the first substituent have a lower number. So we decide from this as number 1 position. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And then we're ready to go to name. The longest chain have 9 carbons. So we name the compound, start from the last part. The last part will be no name. Okay. And then we attach all the other in front of the no name. And remember, there's no space. Okay, no space between the no name and all the substituents. And so we decided from this is number 1, number 2. Number 2 has a methyl. So we have a methyl group. Whenever you name compounds, draw the line structures. You are not given the line structure, you still need to draw the line structure to help your naming. Do not leave your compound as the condensed structure, because it's going to be very hard to see the branches with condensed structure, as you can see from practice. Okay. 2, 3, 4, 5. 5, we see this group. 5, we have this group. If you remember from the previous slide, this is isopropyl. Isopropyl. Position 6 has a methyl group again. And the 7 has this group, ethyl group. Okay, we have ethyl, 2 methyl groups. So the name, we have 3 different groups, methyl, ethyl, isopropyl. Alphabetic order is ethyl will go first. So we put ethyl is the first one in the naming. Position 7 has ethyl, so I write name as a 7. Ethyl. The next group, isopropyl. Okay, in this case, iso is part of the name, is part of the name. So the isopropyl should go before methyl. Isopropyl is on position 5. So position 5, we add isopropyl. And then we, between the group, we have the hyphen, okay? All of these are hyphen. And finally, we get to the methyl group, position 2, position 6, both have the methyl. So 2, 6. There are 2 methyl group, so add a di. Okay, run out of space. And toward the end, do not leave space between the last ill with the parent name. No space. Okay, so one word. Leave no space. That'll be the name for this big molecule. Okay, so that's the naming compound. Drawing structures, drawing bound line structure. This is easy. Okay, drawing bound line structure easy based on name. The key is you draw the last parent first. Draw the parent first. Cyclohexane. So you just draw the cyclohexane. 6 carbons. And then you have all the names. Position 1 has butyl. It does not matter. You can pick any carbon out of cyclohexane as the number 1. It does not matter because now you have a lot of freedom, okay, with the drawing structures. Drawing structures is much easier. It's fun part. It's fun part of the organic chemistry naming. All right, so let's pick this one as tert-butyl. Tert-butyl. The reason why this one is the first group to name it is tert does not count. Alphabetic order, we look at B. B is higher up in the alphabetic order. So tert-butyl has 4 carbons and they have this kind of structure. This looks like a tripod. Okay. And this is number 1. And then 3 have a cyclopentyl. I'm running out of room in the lower part, so I put a 3 here. This will be my 3. 3 have a cyclopentyl. Cyclopentyl means that 5 carbon with a ring. This is cyclopentyl. And then 2 is ethyl. 2 have 2 carbons. And then finally 4 methyl. This will be for position 4. And that'll be the molecule we're using word to describe. You can see we have 4 different groups. butyl go first, cyclo because start with C goes second, acyl is next, methyl is last as a substituent to write structures. Naming alkanes, these are good practice. I think you should practice yourself. Oh, the bicyclic alkanes. The naming will keep it very straightforward, not so much complicated. And you can see the because tetrahedral and the carbon can form 4 bonds, you can build molecules very fascinating. And this looks like a cage, and this is like and this whatever shape it is. And the compound naming, they still follow the same rule. The number of carbons determine how we name the carbon, like we go over last time. 8 carbons, and that'll be octane in the end. 7 carbons, heptane, so forth. But the difference is it has since have 3, it looks like 2 rings share 2 bonds, and we call it bicyclo. Okay, bicyclo for this kind of ring structure. And for the bicyclic compound, it looks like interesting, intimidating, but the basic rule is you name the longest side arm first. Longest side arm first. If you have 2 arms, this one has 3 arms. If 2 arms have the same length, then whichever arm gives the substituent low number, that has high priority. So that's the same rule as we name the open chain alkanes. And so you can see this compound, this side of the side arm has 3 carbons. Okay, these 2 atoms we call them bridgehead. Okay, and so this is the side arm, and this arm has only 1 carbon. This arm has 2 atoms. So the ordering, we give the longest arm, name that first. And so we can either start from this is number 1 or that is number 1. It doesn't matter. And so 1, 2, 3, 4, 5. 5 get to bridgehead, and then after 5, you number the second longest arm, which is the 2 carbon arm first. So 5 and 6, 7. Finally get to the last atom. This will be the number 8, 1 atom in this arm. And so the location for the methyl group will be the 8. And yeah, so this is the these 2 is basically when you have these 2 both start from the longest arm as the first one to number. But if you this second longest arm have 2 carbons. And so you can start from this number 1 and then go that. Remember consecutive. Okay, remember consecutive. It is basically the 1 is the bridgehead, 5 is the bridgehead. So 2, 3, 4 is 1 arm. 7, 8 is the second arm, second longest arm. 1 carbon in the last number 3 arm. And so between these 2, regarding the methyl group, if you name order this way, the position 6. If you order the other way, you end up this methyl group number is 7. So this is not the correct way. You should name this way. Okay, so that's about the only thing different from the bicyclic compounds. Other than that, it's pretty straightforward. And so these are the 2 compounds, and the rules apply the same way. And so this naming, I will not really explain how to do that. It's pretty straightforward, number those. Make sure you give the substituent as low number as possible. Okay, the first substituent, the low number as possible. In our exercise or quiz, bicyclic compound is not very super important, but you should be aware of the basic rules, how we name the compound. And that's about it. The name is a bicycle, and in the bracket, we start from the longest arm, how many atoms? So this is the longest arm, 3 atoms, 3 carbon, 2, this is second longest, 2 carbon, and the last carbon is the last carbon in this, the third arm, it's only 1 carbon. And there are 8 carbons in the main chain, okay, not counting the methyl group, so the name is octane. It's pretty straightforward. Okay. And for this compound, remember in this last slide, it shows there are two ways. In one of the numbering, it shows the methyl group on the position 7. But this is actually the better give you because the methyl group on the position 6. So the name will be 6-methyl bicyclo 321 octane. The location difference is the methyl group. This is on the number, the shortest arm on carbon. And this one, the second arm, have the methyl group. So that's about the bicyclic compounds. I will not go spend too much time on that.